Now we're going to work on the domain and the range of the secant. Okay, so this graph over here is the secant of theta. So secant theta is defined on the y-axis and theta is defined on the x-axis. Now when we're worrying about domain, when we're looking at domain, we pretend we're a little person walking on the x-axis and we look up or down. And the question is, when we look up or down, are there any points in the graph that we don't, or any x values that we don't see a graph? So we don't see a graph at negative 3 pi over 2. When we hit negative pi over 2, if we look up or down, we don't see a graph. At pi over 2, we don't see a graph. And 3 pi over 2, we don't see a graph. In fact, it looks like, excuse me, any pi over 2 plus pi in either direction here. So what we're going to do is we're going to write it like this. Excuse me. So this will be, let's write this down. The domain is going to be all numbers. So theta is our variable such that theta is a real number. So it can be any number at once, with the exception that theta is not equal to the following: pi over 2 plus k pi, where k is an element of the integers. So what this does, guys, if you think about kind of the, I'm going to write here, pi over 2 plus k pi. Well, what kind of values do you get out? Well, k is an integer, so that means k is one of these guys. Since k is one of those guys, if I plug those in, let's start out with 0. If I plug in 0, so I'll write it like this. When k is 0, we get pi over 2 plus 0 pi, which is pi over 2. That is, let me erase these. Let's just erase this whole graph. That is this guy right here. So of course at pi over 2, we don't see anything. Now let's try when k is 1. When k is 1, I get pi over 2 plus pi, which is pi over 2 plus 2 pi over 2, which is equal to 3 pi over 2. That's that guy. And of course, I don't see anything up or down here. We can continue. K is equal to 2. If you work it out, you're going to get 5 pi over 2. So you're going to get all those odd multiples. Now, what about the negative direction? Well, when k is equal to negative 1, you're going to get negative pi over 2. So you get this guy. And when k is equal to negative 2, you're going to get this guy. So it works back and forth in both directions there. So this up here, okay, is what we want to write for the domain. We want everyone except for those values. So now I'm going to erase this and I'm going to talk about the range. Oops, I erased my theta. And that's alright. Okay, now what's the range? So the range, we pretend we're a little person walking on the y-axis, because range is y's, domain is x's. So I'm going to walk, and I'm going to ask myself, when do I see graph? Well, I see graph from negative infinity all the way up to negative 1. So basically what that's saying is, from here down, I see graph. So from negative infinity to negative 1, and of course I include negative 1 because at negative 1, look, I see a graph. Now I see nothing in this area. So I want to skip that area, and now I want to start, the next time I see something, is at positive 1. And that goes all the way up to infinity. So I want to go from positive 1 all the way up to infinity for my range. If you pretend like you're a person walking on the x-axis for the domain and the y-axis for the range, I think you'll find yourself to be very successful being able to establish what domain and range are.